Hi students, Himanshu Pandey. Advanced Problems in Organic Chemistry, GOC 1 to 6 already uploaded. Now we'll see 7 onwards in the part 2. In which of the following pairs of resonating contributors is the structure on the right important contributor? Right side, which one is important? Nothing but stability. So right side one is stable. For example, how it is stable? Remember friends, it is if octet configuration is there, that is generally stable. So here this carbon is there, have only 3 bonds. 3 bonds means 6 electrons. But here you can check carbon has 8, oxygen has 8 electrons. So this is stable. Both are at octet. Similarly, here C minus with 3 bonds and 1 lone pair, negative charge means octet. N is octet. N is octet. Here also C is octet. N is octet. N also octet. Here N minus means lone pair. How many? 2 lone pairs. Then which is the stable one? C minus, N minus. I said more electronegative atom, more stable with negative charge. And this is stable. C plus is there. No octet because 3 bonds only there. H1 bond, these 2 are. And it is only 6. But here every one, even oxygen O plus is there. Octet configuration. With OH, 1 bond is there. C and O, double bond, lone pair. Total, if you count 8 electrons will come. Here 6 only, but here 8. Every one at 8 electrons. So, all the above, right side ones are more stable. Examine the following resonating structure of formic acid and arrange them in decreasing order of stability. This is for formic acid. Which one is here more stable? Remember, first neutral one is more stable. Then charges with octet configuration more stable. So neutral, and next here oxygen lone pair is there. You must remember O plus means lone pair is there. How O plus will have a lone pair? See, oxygen means it has 6 valence electrons, right? 1s2, 2s2, 2p4. 6 valence electrons. Now it has, for example, 3 bonds like this, and there is a positive charge. Out of 6, how many electrons are there only with oxygen? 1, 2, 3 belongs to oxygen. So plus means out of the 6, plus is there means 1 electron gone. 5 electrons. 5 means only for oxygen, 3 are there. Therefore we should keep lone pair. Okay, so here with this 8 electrons are there. Here O minus means, remember, 3 lone pairs are there, including for minus charge meaning 3 lone pairs and a bond pair. So here octet configuration is there. Here also octet configuration is there. First neutral and second one is this. Carbon also have 4 bonds. Octet configuration is there. Next 2, let's see. Here C plus only has 3 bonds. 3 bonds means 6 electrons are there. Here O plus means 2 lone pairs because it has only single bond. Out of 6 electrons, plus means 1 gone. 5 electrons are there. Those 5 of oxygen. This is 1, 2, 3, 4, 5. And around this, if you check, electrons only 6 are there. No octet. Got it? So 1 greater than, 2 greater than. Now 3 and 4, which is stable? Both of them missing octet configuration. Then which one is stable? More electronegative atom, negative charge stable, positive charge unstable. So this is unstable because O plus. C plus is stable compared to O plus. So 1 greater than, 2 greater than, 3 greater than 4. This is the answer. The next one, which of the following compound will not show resonance? So here positive charge is there, means empty p orbital is there, carbon positive charge means there is one orbital is empty. So these electrons can move like this. Resonance is possible. But whereas N plus, around N already octet configuration is there. And for nitrogen 2s and 2p orbitals second period, total 4 orbitals are there. Total 4 orbitals, total 4 bonds only maximum. So how many bonds already there here? 4. So in this option you don't find the resonance. The rest all cases possibility is there. Which of the following compound will exhibit a d orbital resonance? Here d orbital resonance, oxygen second period. Second period means no d orbital. So here no d orbital. And here chlorine third period, d orbital is there. They are asking MT exhibit d orbital resonance. So here lone pair is there. That lone pair is coming towards benzene. So those are not in the d orbital. These lone pairs not in the d orbital. Where those are there? Like 3s2, 3p5. These all lone pairs from the s and p orbitals, not from the d. Remember, here phosphorus is there, and here this phosphorus has an empty orbital, and to that empty orbital from the benzene electrons are moving. So here from the third period we can say expecting electron from the benzene electrons are moving to empty d orbital because phosphorus has an empty d orbital. And which of the following represents the resonating structures? Resonating. So from here, 2 benzene rings biphenyl it is, pi bond, sigma bond, pi bond, full conjugation is there. Such a way here you can see there is a positive charge, sigma bond, again pi bond, sigma bond, negative charge. So conjugation everywhere is mentioned, everywhere is there conjugation. So all the above have conjugations. Here the pi bonds in one place, here the pi bonds move to another place. For example, like this the pi bonds are moving, like this the pi bonds are moving. You got this. And which of the following is not permittable resonating form? Which is not a correct resonating form? I said here second period element, it don't have a d orbital, maximum 4 bonds only possible. Here you can see directly nitrogen has how many bonds here? 5 bonds. It is not permitted. So this is not permitted according to the question. And less contributing structure of nitroethene is less contributing nitroethene. Okay, so you can see here first neutral one is more stable, or else less charges fine. Here only 2 charges are there. Here 4 charges are there. Here also 4 charges are there. Here also 4 charges are there. So most stable is the first one. They're asking least contributing means least stable. So out of these 3, which one is highly unstable they are saying? Remember, 1 plus 1 minus adjacent or side by side, they are stable. Got it? But a plus and plus, if they are side by side, highly unstable. Which of these will be least stable resonating structure? Again, so you can see here nitrogen lone pair wants to come towards like this double bond, but when nitrogen lone pair and adjacent negative charge is there, negative and lone pair electron negative, repulsions are there between these two. This is what least stable. Remaining all the cases they fulfill the resonance stability whatever requirements. Got it? Which will be the least stable resonating structure? Again structure here, remember there is a day 2 bond is there. Day 2 bond means like this. If you write a normal bond, imagine normal bond means here minus will come, here plus will come. Day 2 bond means here minus will come, here plus will come, which is a donor positive charge, acceptor negative charge. Now here what I told you, when positive charges are very close unstable, similar way you are finding here. See, positive charge of nitrogen, C plus